Alright, so we've got Baxter's Bros pool party. Baxter's with his bro, and they're in the pool and they're playing Marco Polo. We've been given some information. Now, I've drawn some information, but I haven't drawn all the information. What information am I missing? What angle?
140 degrees.
So you know that this 140 was maybe we'll just get this angle here. Very good. So Taylor says it's 140. Is Taylor right?
Yes.
How do we know if she's right? Because nowhere in that question do I read 140. So I know that this angle here is 30, correct? And I know that this angle here is 10. So 180 minus those two together, which is 40, leaves us with 140. Very good. So can we see how we got to calculate the distance? What type of problem are we dealing with here? A cosine rule, correct? How do we know it's a cosine, not a sine rule?
Because you've got two sides of it.
And I might call this side A instead of D, doesn't matter what I call it, correct? So then I apply my cosine rule, which is just simply what? We should be able to say it off the top of the head.
A squared plus b squared take 2ab.
Not 2AB, 2BC.
BC.
Pos A, if I could write the words, that'd be good. Very good. And then we just sub our values in and solve. We want what? A, so we just leave that on this side. So we get 50 squared plus 70 squared minus 2 by 50 by 70 equals 140. And what do I get? A squared equals?
12,762.
12,752, you said?
63.
0.31, thanks, that really matters with the distances. Now we're going to have to do what?
Square root of 100.
And we get 112 metres. Does that sound a reasonable amount? If we look at the problem, I've drawn it relatively to scale. Does that look like a reasonable amount? So one of the things with these type of problems, if we can draw reasonably scaled diagrams, life is a lot easier because we can go, that looks reasonable. That looks like a normal amount. It's a bit of a check for us. Also, so question A is done. Now question 2, and this is the more challenging component. I need to find the bearing from who to who. So I need to find the bearing. Like imagine I've got use my black pen here. Imagine I've got and I need to find that angle there, correct? A bit tricky though, isn't it? What do you think will help? Z rule definitely will help. So I know that I want to come back to the Z rule. The Z rule must be used, but you are 100% correct. But I just want to do something else before I apply my Z rule. How many things do I know about this triangle right now?
All sides and one angle.
All sides and one angle, correct? I can find, using the Z rule, I can find this part here, correct? I know that that side is what? How big is that? 10? But that's not what the question's asking, is it? Is the question asking for that or not? What's it want to know? It wants to know this little part here. I'm just going to colour this purple part in. It wants to know this angle here. Now the 10 is helpful, but it doesn't tell the whole picture. So what do I need to do to find out that?
So you have to use the sine rule to find the whole angle and then subtract 10 from it.
Very good. So I'm going to use the orange part, right? I need to find that total angle, correct? And the way that I use that is my sine rule. So what if I call this side, pick a letter B, then this angle's got to be capital B. So I'm going to use sine, I'm going to do it in orange, sine B over B equals sine A over A. I'm going to fill in some values. So I've got sine B over 50 equals sine 140 over, what did we say it was, 112. 50 sine 140 over 112 on B, and I get B, Brad, what do I get B to be? Yes, B, be putting it in your calculator.
Yep. That's. Don't.
Is this an ambiguous or a non-ambiguous case? Is there two possible sine angles or only one?
Zero. Doesn't not make sense.
There is only one. Why is there only one? I already know this angle is 140, correct? So if this angle was any bigger than 90, would the angle inside the triangle be over? We can't have the angle in the side of the triangle being over 180, so we know this angle's got to be less than 40. Does that make sense? So you were telling us, Brad, what's...
Oh, yeah.
You're not almost done, okay. We'll just wait.
As you know, that angle is 10 degrees.
0.68 degrees.
16 point what?
68 degrees.
Now Taylor just asked a good question. She said, how did I know that this angle here was going to be 10 degrees? Happy with that? So I'm just going to take, because it's getting pretty messy, this diagram, I'm just going to take this part out, okay? So because those dotted lines are parallel with each other, I know that that angle there is 10, which means that this angle here must also be 10. Cool, so I've drawn an imaginary north line. So what's the bearing?
6 points.
So the bearing is 16.68 minus 10, 6.68 degrees true. Now if I wanted to do a compass bearing, what would that be? North 6.68 east. Happy with that? Great. Now what we're going to do, because I don't know if we're fully onto this yet, we need to find this third part of this question. So I've done the first two. I'm going to leave you to the third one. The third part of this question is bearing from Brad to his boy Bass. Let's go.